Today we're looking at notes KK-3, rationals, crossing HA, crossing the horizontal asymptote, never the vertical asymptote. So I have to tell you the truth. We've been holding stuff back from you all these years. The HA actually describes how the function behaves at the ends, not in the middle. So you can cross through an HA. Okay, never a VA, but you can cross through the HA. So to test, set the horizontal asymptote equal to the function. If it can be solved, that's the point of intersection. And it is x, comma, whatever the HA value is. Okay, so test to see if the function crosses its horizontal asymptote. So you should know that this horizontal asymptote, because of the degrees, numerator is bigger, the horizontal asymptote is y equals 0. In both of these cases, my degrees match in the numerator and the denominator, so we'll look at our coefficients. So for this, it's y equals 3 over 1, and for this, it's y equals 4, because 4 over 1. Okay, so now, let's test. Set the HA value, which is 0, equal to the function, so negative 3 over x minus 4. So of course, I'll put the 0 over 1 and cross multiply. 0 times the denominator would give me 0 equals negative 3. That's not true, so does not cross. Okay. Look at number 2. So 3 equals the function 3x squared plus 11 over x squared plus 3. So put the 3 over 1 and cross multiply. So 3 distributes into the denominator, so 3x squared plus 9 equals 1 distributes, which would keep the numerator the same. Okay, of course my 3x squareds can simplify out, which would leave me with the statement 9 equals 11. Not true. So does not cross. I bet you guessed it. I bet you think this next one's going to cross. Let's see. Okay, set my HA equal to the function 4x cubed plus x squared plus 9x equal x cubed minus 5. Okay, put the 4 over 1, cross multiply, make sure you distribute the 4 into the terms of the denominator. So 4x cubed minus 20 equals, when you distribute 1 into the terms of the numerator, of course all the terms stay as they are. Okay, so my 4x cubes simplify. I'm going to 0 equals x squared plus 9x plus 20, because I saw I had quadratic here, so I knew I was going to have to get all my terms to one side of the equal sign. I wanted that positive a value. Okay, so now I'm going to factor 0 equals x plus 4, x plus 5. Okay, so it is solvable. My solutions are x equals negative 4 and x equals negative 5 if I set each factor equal to 0. So therefore, I crosses at negative 4, comma 4, and at negative 5, comma 4. Of course, this is because, let me point, the negative 4 obviously came from here, the negative 5 came from here. Both of these came from up here, the y values came from the asymptote. Okay? So let's go ahead and practice graphing with this new founded knowledge. On each problem, find A, the roots, B, the vertical asymptotes, C, the horizontal asymptotes, D, the y-intercepts, E, does it cross the HA, and F, graph. So roots, I'm going to go ahead and fill this out. Numerator equals 0, denominator equals 0, HA is degrees, y-intercept is x equals 0, and does the HA equal f of x? Can we solve that? So for the numerator, let's look. This polynomial is not factorable. So when we set x squared plus 2x plus 3 equal to 0, we're not going to be able to factor. We're not going to have any roots. No roots here. Okay, next, denominator equal to 0. Okay, square root both sides. So x equals 0. Degrees. The degrees match. So numerator equals denominator. So that would be y equals 1, because my coefficients are 1 in the numerator and the denominator. X equals 0, so this would be y equals 3 over 0. So that would be undefined. Remember that. Use this pink color so it stands out. Undefined. So that means none. Crosses HA. So HA, which is 1, equal to my function. So I'll put this 1 over 1, cross multiply. So x squared equals x squared, plus 2x plus 3. So here, my x squareds undo each other. So negative 3 equals 2x. So x equals negative 3/2. That's where I cross. So therefore, negative 3/2, comma 1. Remember, this comes from here, and this is my HA. Okay, so let's start graphing. Where did my pencil go? Oh, there it is. Okay, so no roots. VA is x equals 0. So VA on the y-axis. Okay, HA is at 1. And so no roots, VA, HA, no y-intercepts, and then crosses the horizontal asymptote at negative 3/2, 1. So right here. So what that means is this graph is still going to hug this asymptote, and it's still going to hug the horizontal asymptote. It's just going to cross it. It's just going to cross it, but then it's going to bounce back and start hugging it again. It won't cross it again because there was no other x values that worked here. So you're going to cross it through that point, and then other than that, you're going to start to hug the asymptote again. Over here, we don't have any x-intercepts, so we know that this shape is going to be over here and above the asymptote, and we know we're not going to cross the horizontal asymptote over here because we did the only x value for the point of crossing is negative 3/2. So that is your shape for this graph. Okay, let's practice another one. So number 2. Okay, so numerator equals 0, denominator equals 0, degrees, x equals 0, HA equals f of x. So let's try and factor first. So the numerator is factorable. We would get x minus 1, x plus 3. Denominator also factorable. plus 2x minus 2. We have that difference of squares, no wholes. Okay, so numerator equal to 0, so that would make roots, so they need to be coordinates. So that would be 1, 0, and negative 3, 0. Try and go faster for you. Denominator equal to 0 for my VA. These are lines, so x equals negative 2, x equals positive 2. HA degrees, my degrees match, so coefficients in front, so y equals 1. Y-intercept is where x equals 0. So I'm going to look, to me in this case it's easier to look at this version. So negative 3 over negative 4, which would be positive 3/4. And then does it cross the HA? Well, 1 equal to x squared plus 2x minus 3 over x squared minus 4. So of course you're going to do 1 over 1. So you're going to get x squared minus 4 equals x squared plus 2x minus 3. Those x squareds would undo each other. So add 3, so negative 1 equals 2x. So x equals negative 1/2. So negative 1/2 comma 1. Okay, let's start drawing. Okay, so we have roots at 1, 0, roots at negative 3, 0, VA at negative x equals negative 2, as well as x equals positive 2, HA at y equals 1, and y-intercept at 3/4, 0, 3/4. And then we cross through the HA at negative 1/2 comma 1. So that tells us a lot. Okay, that tells us a couple of things. So here, since we don't cross the HA here, the shape must look like this. Okay, shape must look like this. We don't cross the HA here. We do cross the HA here, so this tells us a lot too. We must have the cubic shape. Look at that. We're going to hug the asymptotes, and since we don't have any more roots over here and we don't cross the HA, this shape must be this. Cool. Next example, last example. So let's factor first. Oh, pre-factored. Nice. Y equals x plus 1, x plus 1 over x squared plus 2 is not factorable. So actually, since it's pre-factored, we really need this form. X squared plus 2x plus 1 over x squared plus 2. We really need both forms. Okay, it helps a lot. So numerator equals 0. Denominator equals 0. Degrees. X equals 0. And HA equals f of x. Alrighty, so numerator equal to 0. For this, I'm going to look at the factored version. So that would tell me that I have a root at negative 1, 0. VA, denominator equal to 0. You probably already recognize this. X squared plus 2 equals 0. Remember what's going to happen. You're going to get that imaginary situation. So none. Remember from before that this none here means mountain when you have no VAs. Okay, degrees, this is where I like to use this version. Okay, my degrees are the same. Numerator equals denominator. So y equals 1 because my coefficients in front are 1. Y-intercept, x equals 0. So again, I like to use this version. So that would be y equals 1 over 2, because 0, 0, 1 would be 1. 0 plus 2 would be 2. 0 plus 0 plus 1 is 1. And then 0 plus 2 is 2. So 1/2. So 0, comma, a half. Crosses HA. Well, let's see. The 1 equal, again, this is where I like to use this version. You really need to use this version. Cross multiply. Okay, so I'm gonna come around here. So this is gonna be x squared plus 2 equals x squared plus 2x plus 1. So then we get, move the 1 over, so 1 equals 2x. So 1/2 equals x. So 1/2, comma, my HA is 1. So let's start graphing. No VA. HA at 1. Again, that's a commonly used HA, isn't it? Okay, I have a root at -1, 0. No, yes, okay. Y-intercept at 0, 1/2. And then crosses the HA at 1/2, comma, 1. Okay, so what that means is, since that's the only place I can cross, and I have my mountain, it's going to do something like this, to where on this side it starts leveling off eventually, and it's going to hug the asymptote here. Here, I'm going to cross, and then I'm going to start hugging again. Okay, I knew that this had to be the high point of the mountain, because again, I'm not crossing through. I don't have any more roots, so this must have been the high point, and then it started leveling off and hugging. And here, we knew that these points existed. It cuts through, but then it doesn't cut through the HA again, so this must be the shape.